first speaker is Vadim Makeev. He has been doing front-end for quite a while now, and he's quite well known among, especially among Russian-speaking engineers, because he, among other things, he is the founder of the web standards community. He's also the host and the producer of several podcasts, which is how I know him, where I know him from. For all Russian speakers here, I would really recommend the Web Standards podcast. I think it's a great way to stay up to date with everything that's going on in the web platform. And today he has some audacious things to share about adaptive web applications. So please welcome Vadim Makeev. The floor is yours.
Okay, hello everyone. Should I share my screen first, I guess? Yeah.
So basically, it told the audience everything they need to know about me, but you said that usually your speakers, they know what they're talking about. That's a lot of pressure right now, but I'll try to keep up. Anyway.
Well, I mean, if you're here, I think you already know.
Okay, thanks. That's a lot of trust. So I'm actually Vadim, and I'm going to talk today about the conditionally adaptive interfaces, conditionally adaptive CSS. So we're going to focus on performance, CSS, and things like that. Just a few additional words about myself. So this community, WebCore, is based in Amsterdam, Netherlands. Currently, I'm based in St. Petersburg, Russia, but there's actually one thing's going on right now. I'm in the process of moving to Berlin very soon. So next week I'm gonna arrive to Berlin and stay there for a while. I don't know for how long. I'm gonna live and work there. If you don't know why the tractor, ask your Russian friends and they'll explain to you the joke. So yeah, you'll find me soon in Berlin and in Europe, I guess. We'll see each other on conferences or meetups. But for now, yep, I'm here online from St. Petersburg, Russia, and we're going to talk about CSS. CSS in general, and then some things related to loading, including CSS to your web pages or web applications, and performance. That's the main subject today. So CSS, how we usually write it. There is an idea among web developers these days that modularity is good, meaning that we usually don't write a CSS in a single file. We usually have a number of files, usually like a lot. Sometimes like per page, sometimes per section on your page, sometimes per every icon. Sometimes you have, I don't know, atomic CSS and things like that. But in general, usually it boils down to a single file at the end. So you have a lot of components, you have a lot of modules or whatever you call it, but in the end you have a single CSS bundle, whatever you call it, index CSS, style CSS, or just hash sum of this file. And how do we include those CSS files? How we combine them together into index CSS? Well, usually it's imported in some way, well, by using native import statement in CSS or some made up thing that in your JavaScript for Webpack and things like that. And it's all then combined together using some tools. You might know those logos like Gulp, PostCSS. Yeah, Gulp is still relevant in some cases. PostCSS, Webpack, maybe even Vite. So yeah, there are many tools that could pack your resources, combine them together into a single file. And that's what's happening with CSS usually. And once it's all combined, we have index CSS file. Well, usually it's like this, index CSS. And it's usually huge. I mean, compared to your typical JS bundle, it's tiny. Compared to a typical GIF, like 10 megabyte GIF on your page, it's tiny. But there is a problem with this CSS. It's blocking rendering while loading. So nothing's going on. But more on that later. So We're writing our CSS modular these days. That's good. We're combining it together into a single bundle. But what's going on inside of this CSS? Well, in modern interfaces, they have to be adaptive, meaning that you're using mobile, you're getting one version of your interface. You're using tablet, you're getting another, desktop, and yeah, everything in between. So basically, you need to use some sort of way of adapting your interfaces. And historically first and quite common is mobile first. How it works? You have, for example, you have a component called header, and you want to specify tomato color for the text of it for mobiles, for mobile devices, and yeah, for small breakpoints, I would say. And you just write it down as is, header color tomato. Then at some point, at some breakpoint, you want to have different color, and you write it down like this: min width 768 pixels, and then color plum. And then you do the same thing for desktop breakpoint, for example, but with a different color. And you know, the way it works reminds me of paint. You see, imagine you have a bucket with tomato paint. What is happening right here? You're taking this bucket and you're just pouring it over your page. Yeah, everything is tomato. Then you make a few steps further, and you're taking another bucket of paint and you're pouring it over tomato. And starting from this point, everything is tomato, and then everything is plum, for example. And then you're making a few further steps, and you're pouring another bucket of paint. And it becomes a little bit messy, if you ask me. I mean, you have to override some properties, some styles. And in most cases, it's not just a color property. In most cases, it's more than that. It's display grid, display flags, some margin spottings, and a lot of different parts of your interface that has to be changed because there is a certain breakpoint reached. So it becomes, yeah, quite messy. That's why it's usually complicated when you're exploring the other people's code. But when it's yours, well, we get used to it. There's another approach called desktop first, and it works, yeah, almost the same. But instead, you specify desktop color first or desktop styles first, and then you say max width. So it's maximum width when those styles would apply. It's super complicated. It takes a few seconds for me, like almost every time, to read those things and wrap my head around it. And yeah, so you're starting from desktop and you're going towards tablet and then mobile, and you're getting pretty much the same result. And again, it's the same messy thing. You have to override your styles, but you're starting from desktop and you're going not from 0 to infinity, pouring your paint buckets all over the place, but you're actually starting from desktop and you're going towards the 0. But it's the same thing. And in the end, we're getting something like this. Just a sec. We're getting something like this. Some people might call it beautiful. Some people got used to it. But yeah, it's modern art. No, it's just a state of the art. I mean, that's what we do these days. And we got used to it, and we probably don't have a choice. Well, I guess. What's next? Next, we need to include your resources, your styles to your page. And if you think that I'm telling like typical thing that you already know, yeah, that's true. But I have to remind you all those things before I reveal my new ideas regarding this. So bear with me. So once we adapted our interfaces, we need to do something with linking it to our pages. What we usually do? Well, that's it. Link rel style sheet, href, index.css, done. Some people in some project they also include Google Fonts and some external resources sometimes like Bootstrap and things like that. If you can, please avoid doing that. External CSS is also rendering, blocking rendering, and it's different location, and it takes time to get it from other websites. And some people, like best of us, they also include print CSS. How it works? We usually include extra CSS file and then say, okay, when media is print, and so when we're printing something, then apply these style sheets. So browsers, so those styles are locked by print media. They are not applied to your regular web pages. Yep, it happens. Some people also, some people also split some parts of their interfaces. For example, help pages, catalogs, galleries, and things like that are not essential on the main page. So they could make their CSS bundle smaller. And this is the good thing. Please try to implement something like this to your CSS bundle. It will help the initial rendering on the main page. Yeah, and everything I just explained to you combined somehow affects performance of our websites and web applications. And usually in a bad way, because we're combining everything together. And to understand the problem, we need to go through the things you probably already know, but we need to go through to focus on them to understand the problem better. So how page rendering actually works. Browser requests the page. I'm not going to go through the whole process. I'm going to focus on CSS only. Browser requests the page. What is the page? It's HTML. So HTML starts loading. It actually starts streaming, meaning that browser can actually parse it and understand and take some resources out of it before it finished loading. So browser usually finds some styles. And once browser sees files, CSS files, it starts loading them like crazy with the highest priority possible. Because when you have HTML and CSS, you can combine them together and render something. And browser is trying to render something as soon as possible. So styles start loading, and once more styles are found, included in your HTML or imported in your CSS, browsers start loading another styles, and CSS loading again and again and again. So it sounds, I mean, I'm trying to make it as slow as painful as possible, but it really depends on loading CSS. And while this is happening, our user sees exactly this, meaning nothing at all. Our pages are blank until we have all the CSS we have, all the CSS we included to our page. Why is it so? Because CSS, just like HTML, it could be actually parsed and rendered declaration by declaration, because it's declarative, just like HTML. But since CSS is cascading, you can override some styles on the first line of your CSS file and the last line of your CSS, meaning that you have to load all the files you have to actually start rendering. That's the beauty of CSS. That's the curse of CSS. And once we have everything done loading, let's render something. And it might sound lazy, it might sound inefficient to you, and you want to say to your browser, you just go home, you're drunk, you're too lazy, you're too slow. But to be honest, we don't have a choice, really, because first of all, browsers are not lazy. They're doing everything in their power, and they're constantly improving to render your web pages as fast as possible. It's their business. They're not just being lazy. And unless you have some C++ skills, there's nothing much we can do about it on browser side, because it's already super optimized. So we have to do something on the side of our applications, and we have to somehow, I don't know, think different. I probably know the company behind the slogan, but let's try to CSS different first. Imagine you have some website. Like I took some random web dev page. Well, not random, it's a learn responsive design by Vadim Makeev. I highly recommend reading this. It's the ongoing part of this web dev platform. And you have desktop and some tablet design. And you have different styles for each breakpoint. For example, we're going to style this menu. I'm not going to use the real CSS from WebDev website, but I'm just going to use some fake styles. So imagine we have menu. And those styles like margin, padding, list style, you need it on every breakpoint of this website, because it's just basic browser defaults that you need to reset somehow. Margin, padding, list style. It's because there's a UL HTML element used. It's you don't have to be smart about it. You need it. You need those styles, your base styles, on every page of your site. Then for tablet layout and for mobile layout, like starting from breakpoint 768 pixels, we need some certain styles. And if you look at this, I say starting from this breakpoint and less, meaning that I'm isolating my styles between 0 and 768. So they're not just poured over the place. They're not spilled around. I'm isolating it in a certain breakpoint. So those styles will be applied only to breakpoint from 0 to 668 pixels. And then when I need to do something for desktop, I can do something like this. So starting from more or equal 768 pixels. And I can do something completely different. It was grid layout on the previous breakpoint and flex layout, and they don't interact with each other. They don't affect each other in any way. So I have two separate buckets of paint instead of just a mess of a paint on a single surface. And that's the idea of this CSS different. And you might ask, what is this? You might ask, what's the width less than 768 pixels? Because usually it looks like this: max width, min width. It's actually a new syntax of media queries. So you can actually write your media queries in human language. I mean, it's not human language, but still, it's much more easier to understand. So it's already supported in Firefox. It's gonna be supported in Chrome Canary very soon, or maybe it's already supported in Chrome Canary. So I expect next year it will be available in Chrome and Firefox stable, and probably in Safari someday. Maybe they'll catch up sooner this time. So yeah, you can do this width, and you can do this with more or equal, and it will be translated to min width 768 pixels, like using the old syntax. Or you can even do things like that. You can have like minimum, maximum, and something in between. And this will be translated, guess what, to this thing. It's going to be min width 768 and max width 1023 pixels. Well, it's really unnecessary to do this kind of thing on your own, because there is a post CSS plugin you can do that can do this for you. So if you want to write using this new syntax in your CSS, you can apply post CSS plugin for it, and will be converted to old syntax for old or just modern browsers until we have it in stable browsers all over the market. So yeah, and once I started to write my CSS like that, that's not all the trick. That's not all. I have something else going on in my head, and I thought, what if we can take those breakpoints and separate them into files and include them file by file and ask browser to load only files it needed. Something like this, like base CSS. Remember this menu, margin, padding, list style reset? We can load some basic CSS for every breakpoint, and then include mobile, tablet, desktop, and then probably, I don't know, include some media queries inside of those files and ask browser not to load those files because those media queries are inside of it, something like this. That was my first thought. Of course it doesn't work, because there's no way to tell browser, please stop loading those files because I don't need them at this certain breakpoint. So yeah, it doesn't work, obviously. But then I thought, wait a second. What if we can do something like this? What if we can include our base CSS and then mobile CSS with extra attribute? Remember those print styles? Those are not applied until we're actually printing. And in this case, instead of print, we can say width less than 768 pixels, and they won't be applied the same way. And they won't be loaded probably. You know, we're gonna save some traffic because of it. And we can do the same thing with tablets and desktop, and we can have, yeah, this beauty. Well, of course, we'll need to convert it to old syntax to make it work in modern browsers. Well, in browsers these days, maybe next year where it's going to be easier for us to read and write, but still, and it looks very, very promising. I made a demo out of it, and nope, doesn't work. If you look at the network panel, it looks like this. So you have a demo with the code I mentioned on the previous slide, and we have every file loaded, no exceptions. Base, desktop, mobile, tablet, yeah, everything. Yeah, thank you for listening. Yeah, that was a failed experiment. Well, not really. I realized after exploring a few other panels, a performance panel actually, that it actually works, but not the way it's supposed to or I expected it to. It works like this. So I made a demo. This demo looks like a simple page with a very clear difference between desktop, tablet, and mobile versions. How it works. I have base CSS, just 70 bytes, with some universal styles available for every breakpoint. I have mobile CSS with different background color, and you can look at this CSS and say, like 5 kilobytes? Are you crazy? What did you do? Well, I actually made it huge. I made it bigger by including base 64 graphics to it, just to make it bigger, because I wanted to see the difference. I did terrible thing with tablet CSS. It's already 62 kilobytes, and this 241 kilobyte for desktop CSS. It just, yeah, never do this in production. Never do this even for demo. So I have different files with different weight, and I'm including it in the way I just showed you before, with some media attributes and some expressions in them. And that's how it looks. I went to performance panel and recorded how this page is actually loaded. I used network throttling to like slow 3G or something. And I also enabled screenshots to see how it actually rendered. And this is what's going on here. If you know your performance panel, you could probably tell what's going on here, but don't worry, I'll explain. So right here, we have a waterfall of all resources that are loaded. On this page, it's just a number of CSS files, like 4 of them. And here we can see that some events happening and some page rendered, and this is just a mobile viewport. As you can see, all 4 files are loaded. And how it actually works? As I said, it worked, but how? Well, if you look at this line, this is where the rendering happening. So you can see the screenshot, and you can see DOM content loaded, first paint, and first contentful paint. And it happened not after all the CSS is loaded, but only after base and mobile CSS are loaded. So tablet CSS and desktop CSS are not blocking the rendering, meaning that they will be available very soon once they're loaded, but rendering will happen as soon as we have all the files we actually need for the certain breakpoint. And if you hover over those files, you can see that base CSS was loaded in 2 seconds with the highest priority. And if you hover over tablet CSS, you'll see it took almost 5 seconds with the lowest priority. So by adding media attribute with some expressions to our link elements in our HTML, we're actually lowering priority of CSS, and they're not rendering blocking anymore. So browser analyzes them and makes the decision what's the rendering blocking, what's not. And if you wondered what's going to happen if once I have removed all the media attributes on a typical web page, rendering will only happen when the desktop file is loaded, like 10 seconds later on slow 3G network. So those 3 attributes with some expressions made the whole difference. And this is, that's the magic. That's the point I made this talk, actually, because I realized that it's possible to split your files into separate parts and make them work better, make rendering happen faster. And you can guess what's going on for tablet. We're loading base CSS. We're loading tablet CSS, and once tablet CSS is loaded, we're rendering everything. So first paint, first contentful paint. It just happens that mobile CSS is small enough to be loaded faster than tablet CSS, but doesn't matter, because if it was larger, it wouldn't block rendering. That's the most important part. And you can see those blue dots. When they're bright, it meaning that is high priority. If they're pale, meaning that they're low priority. It's just a quick look. Quick glance, and you can see that those are blocking or not. And the same things happens on desktop, but much further. Because desktop file is larger, I made it larger. It's blocking rendering, but not the other ones. And this is very, 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 very cool. And it's not just the window width that we can use to say browser that those styles are not needed for the current situation. And you can look at window width as user preference. When you're reading your web page like this, it's your preference to read it vertically. If you rotate it, it's your preference to read it this way. The same applies to color scheme, image or screen density, your network connection, and capability of your screen, like high contrast mode and everything. So those are preference. So it's possible to use it for dark mode the same way. I recently I made a demo for my YouTube channel with a switcher. So I have a switcher that switch from day to night, yeah, it works the same way. I have light CSS connected, dark CSS connected, and index CSS. And in those files, I have just CSS custom properties defined, and browser will use only the ones that are matching the prefers color scheme thing, and they will be applied to index CSS. So you can use the same things for Retina, for example. If you split your media queries with background images or something you're using in your CSS into separate files, which is quite easy to make, I think, you can include them with lower priority. They will be still loaded, but with less priority, and only then and they'll have higher priority when they're needed. So it's not a problem on Retina devices. The same thing with prefers reduced data. If you enable this option on your Chrome on Android, I believe it's the only place where it actually works, you'll have this media query matching your preferences, and your heavy CSS with some heavy graphics won't be loaded, or will be loaded with higher priority. The same for animation. If user decided that he hates animations or it makes them sick or something, you can enable this property in their browser or operating system, and your animation CSS won't be loaded with high priority. It won't be rendering blocking anymore. So yeah, it's more than just a window width. It's more than that, and there are many user preferences that we can actually match in media queries. And yeah, I think the most interesting part of this talk you've been waiting for, how to make this work in your code base. So there are some tools that I mentioned already: PostCSS Media Min Max plugin, PostCSS Extract Media Query, Combine Media Query plugins. Yeah, you can do something with them to extract your CSS and yeah, things like that, to go from your modular approach when you're writing CSS in every file for every component, to combined approach when you have multiple bundles for specific breakpoints. There's also a Webpack Media Query plugin. We can do something with your Webpack config probably, but you know, the problem is it's really complicated. It depends on your the way you work with CSS, the way your site is built. So there are many tools to be written to make it work. And at the moment, I have only idea for you. At the moment, I have an idea that your CSS is blocking your rendering while loading. And if you're putting your base 64 graphics and terrible SAS or less selectors that doesn't make any sense and make your CSS bigger, you're blocking rendering. Even if you do just this and you optimize your CSS size, it will be worth it. But if you'd like to go further, you can start from Retina images, you can start from animations, you can start from dark or light theme, and then slowly make your way into splitting your CSS bundle into mobile, tablet, desktop, breakpoint parts, different parts. And at some point, it might work for you. I think with this knowledge for the community, it's totally possible to make it work. But yep, it's in your hands to make it work. You have an idea, you can try and see how it works. And basically, this is it. I have just a few things for you. Just some things that I mentioned here, some demos, some similar ideas by Adam Argyle from Chrome DevRel team. And you can find me almost everywhere using this nickname Pepples Bay, on every social network, in every chat and application, like almost everywhere. I mean, even on Facebook. And you can find those slides. You can open those in browser by this link. It's conditionally adaptive /en, because without slash you'll find the Russian version of this talk, slightly outdated. The English version is a bit newer. And yeah, you can play around with the demo I showed you with those desktop, tablet, and mobile tomato, plum, and wheat backgrounds in your browser using this link, and see it actually that it actually works. And I'm ready to answer some of your questions.
Great. Thank you, Vadim. Just wanted to mention that after this, we will, of course, post all the links to the slides and in the meetup, on the meetup page. And also, once we are done with editing the videos, so the videos will be published on YouTube, and in the description, we'll also add all these links. So you'll be able to follow them. Yeah, so if anyone has a question, please raise your hand. And now, right, seems like we have a very humble and shy audience today. I do have a question, actually. So it seems like with this approach, the key thing is that the browser actually well, respects this media attribute, and it only starts rendering when the well, it starts rendering when all the necessary CSS is loaded, right? So and I think even if you just write this modular CSS in the files, without this, it wouldn't make sense still, right? Well, apart from just the structure of the code, I guess.
Yeah. I mean, if you have like hundreds of CSS files, it will definitely slow down the rendering, because even on HTTP2, it's still complicated to load a bunch of files. So it's better to have single one or just a few of them. And it doesn't matter how you develop. If you want to take the full advantage of this approach, you need to include those files with some hints to a browser, which one of them are applicable where. So first of all, you need to have the same number of breakpoints. Like usually, sometimes it's just 3, 4, 5. Sometimes there are like hundreds of them. It depends on how you actually make it. So if you have like your design just for mobile, tablet, and desktop, it's much easier. But if it's your own product, you usually have different media queries for almost every component, and they could vary a lot. And this makes it much more harder to split those into separate files. But it's still doable, I think. You can split them into groups, not exact groups, but some groups. Oh, I forgot to mention that if you have those media attributes on your links, you can, and you have all the styles with the same breakpoint, you can actually remove media from your CSS. This attribute will replace those nested @media things. So you can just have your plain CSS without any media. But if you have a bunch of breakpoints, you will still have to include those with media in your group of files, a group of breakpoints, and then include the whole variety of this group in this media expression. So it's not a silver bullet, not at all, but it makes you think, like, is there a way I can improve the loading of CSS of my web application? And yeah, if you have fixed breakpoints, it would be so much easier to do. in some cases, it would be almost impossible, I believe.
Yeah, it seems like it's just an interesting approach to like how do you approach the developing the CSS styles. And by the way, I know you mentioned it a little bit, but how does it actually work the same way in other browsers than Chrome?
Yeah, it does.
So Firefox and Safari.
Yeah, and you know, even if it doesn't work the same way, well, I tested, it works. But even if it doesn't work the same way, browser's gonna load them in any way. So it's not like you're gonna lose your desktop version or tablet version if it's not supported. If it's not supported, browser fall back to some basic behavior by just loading and including and blocking rendering. So it's not gonna be it's safe to use. I tried it. I tested it.
Cool. Nice.
But I didn't have a chance to automate it yet. But one day.
Yeah. Well, you started this. Maybe someone will pick it up and do this. Oh, I see there is a hand from Jose. Okay, you can now unmute yourself.
Hello.
Hey there.
Can you hear me?
Yep.
Yes. Okay. Well, first, it was amazing. Nice point of view and nice discovery, nice talk. It was nice. And I remember that in the beginning you mentioned, for example, that we can import CSS on JS, for example. And would that also apply? I don't know if it's well, it's doable by code to have these several files and programmatically import them, but would it have another better way to import multiple CSS files on JS and improve?
I got the question. You know, when you're importing something into CSS by using @import and then specifying the file, you can actually specify the same media queries just like you do in HTML. So you can write import file and then max width something, and it's going to work. But hiding your CSS inside of another CSS file, it's not a good idea, because browser will it take more time for browser to understand that something's going on, and it won't be available to browser at the first moment once it parses HTML. But in JavaScript, it's not the real importing syntax. I mean, it's real for you, like it's real for Webpack. It goes there and it imports and bundles CSS files together, but it depends on how you actually put it in HTML. And by using those imports in your JavaScript, you can actually write a loader for your Webpack that would split those files based on breakpoints and then include it the way I showed you. And this is the only way to make it actually work, to make it performant enough to be useful, to include it in HTML. So it is possible to use the modern import syntax in your JavaScript. There's an idea for CSS modules to be like native ones, not the old CSS modules, but new CSS modules that could be imported into your JavaScript and used in constructible style sheets, all this modern new things. And but at the end of the day, you still need them in your HTML to make it work. So it totally depends on you. Currently with Webpack or some other bundler, you'll have to analyze it and split it into files and then put it in your result in HTML. If you don't have any HTML coming from the server, if you're building all parts of your application on the fly, it will be less efficient. So with server-side rendering, it will work better. But I think it's still possible to to update your head with links for the browser, with those media attributes, and only the needed files will be loaded. So I haven't tried it myself, but it should work this way. But server-side rendering is always better. I hope I answered your questions.
Yes. Thanks very much.
You're welcome.